Okay, we move to volatility. Most of the information I presented right here is coming from other people's work. It's coming from a book called The Art of Memory Forensic. So I go to their website to do a checking. Actually, three authors. They are Michael Lee, Angel Case, and Jamie Levy and Aaron Wright Water. They create a website and deliver training from time to time. Uh, they offer the member analysis in 5 days. The course is to be arranged basically previously in US, Washington, DC, Western, and then right now they are the latest one is offering the online training. The price is 4,600. I try to cover it a little bit, only in one class. So they provide the best training. If you want to go to do the training, you can do it online. So from the Art of Memory Forensic website, you can go here and download different kind of memory dump they provided, and they also have the example question. You can go inside to check the lab question and do the lab answer sheet so that you can practice how to use volatility. And I dig out some example from there and do the demonstration in the later part of the this video. So let's give you some basic idea what's volatility. It is a single cohesive network analyzing memory dump. We call dump, not call the image, because it is only a particular point of a section of the capture of volatile RAM from the physical RAM of the my virtual machine. It can analyze the 32-bit or 60-bit Windows, Linux, Mac, and Androids. Yeah, no surprise. They do a very good job. It is written in Python so that you can check the code, understand how they get the work done through the reverse engineering. So that, as I said, it can run in Linux, Mac, or Windows. I never try Android, but Linux and Mac is okay. Then they can, because they are written in Python library, so you can load the Python module into your Python environment. You can write the scriptable as some kind of scriptable API. So everything is based on reverse engineering. So some kind of comprehensive coverage of file format. You need to understand the physical to virtual memory mapping so that you can read the code very clearly. But in our class, we just give you a basic concept how they do it, and then I'm not going to ask you how to write that kind of plugin, scriptable plugin. And their tool can analyze different kind of format, including raw dump, crash dump, hibernation file, VMware. The best way is to using VMware because the VMware or VM Fusion virtual machine, you don't need to capture the image. Actually, you just copy out the VMEM file or VMS file, or even the virtual coil dump file, so you can analyze them directly without doing image translation. So also the Linux memory extractor called Lime, and then there's another kind of memory dump format is called expect witnesses format, created by one of the famous forensic tool called EnCase. And then, yeah, you can use some other tool to collect the memory dump. And it is fast and efficient because it analyzes it by using the script directly. That you require no GUI interface to wait for a long time to do the indexing exercise. That is create for serious and powerful community competition and researcher. They try to write the plugin to Volatility to allow you to use by open source licensing. It's good for incident response, forensic, and malware focus related. So you can download the tool from the GitHub. So this slide basically summary everything that I talked previously. It first find the KDBG, and then find the KDBG, find the PS active hat, and then based on PS active hat, you can do some kind of the directory table conversion from physical memory to logical memory, and the data structure of the internal data structure of Windows kernel. They create a file type called vtype. Based on vtype, you can using that features to call out the structural information contained inside the physical memory. So if you want to do some kind of KDBG information, you can do the exercise shown in this slide. Okay, that is a new part that I add in this year's lecture. So I said I'm not covering the memory acquisition part, but I still want to show you how they do it. Basically, that is this image, as I said many times, this image is a static port. You can redo many times, but because memory is quite volatile, you cannot redo the image dump every time with the same information. And especially in the situation is memory dump, you are not always be able to using hardware method, because you don't, when the machine has been compromised, it's not easy to insert additional hardware without restarting the machine. Once the machine has been restarted, some volatile information has been lost. So you have to use sometimes using the software. So, but they still have some hardware solution, but it depends on the cost, and the hardware still have some limitation. If you want to collect remotely collect the memory dump, maybe you need to insert the USB and then run the remote tool contained inside the you need to run the tool contained inside USB of the victim that has been inserted in the victim machine by using some remote tools such as PXXZ. That is one way. Of course, you can install the software with the driver. If you have driver, you can check the kernel information easily. Without driver, your tool need to accessing the system API to collect the physical RAM information. And also you need to consider whether you're using the command line program or GUI interface program. For using GUI, such as Ncase or whatever, FTK Imager give you a quite good, easy using click way to collect the image. But that sometimes when you run a GUI interface application, it will create, by running this kind of application, it will automatically create additional footprint and noise on the target, which is not good for maintaining, less affecting the system, as least as possible principle for forensic memory acquisition. So I tend to recommend using the command line solution. Basically, this software using some kind of acquisition way. They try to swap the entire environment in the real time in order to check whether indicator in the physical memory and perform process scanning and collect live response data instead of capture the memory. That way of acquisition of one-time process information, you need to distinguishing. You may only collecting the logical memory instead of collecting the physical memory to do the analysis in more details. In the collecting of a particular running process dump, you only be able to find the information of that process dump. Sometimes you may miss something by collecting the logical memory dump, but that is more easier for you to collect. So you need to make your decision. And also from the one of the paper and from the Hong Kong U Library, you can see that our famous professor, Dr. Chow, and some other peers professor, they published a report on how to acquire the memory acquisition from a two-tick approach. So you have time, go to our library to find this paper for read. So now we, even though we don't show the how to do the demonstration on the main image acquisition, there's a couple of tools that you can consider. If you're using the Max tool, is quite famous, called Monsu tool. Inside the Monsu package, you can have dump-it, Win32DD or Win64DD. And then you can also have bin to dump, dump to bin, hybrid to hibernate to dump. Then you can do some kind of conversion right here. But using this tool, you can using some vendor supply tool. Yeah, supply tool means you need money. Volatility to have some converter called image copy raw to dump. I never tried it, but you should be able to find it in version 2.6, but not free at this moment. So talking about the image acquisition tool, you can use FResponse, quite easy use commercial product. It's some kind of including some kind of runtime interrogation features, just like I described. You want to have a quick and dirty analysis collection. FResponse, a good tool. The FTK imager, when you run in live forensic in USB key, that is GUI interface, you can collect the image of the physical image by using the FTK imager. And also NCase and Belkasoft, they claim that they can have some enter-debugging, more aggressive enter-dumping mechanism present in the GUI interface tool. Whenever you see enter means they are aggressive. Aggressive means they create more noise. So how to balance the content of the non-interference information noise apart from the actual victim machine physical memory content, that is your choice. Also, I prefer to use dump-it. It's easy to use. Of course, you can duplicate, open the command line, type everything, and then it collect the dump for you. But I prefer to select, make sure you check the switch more clearly. Win32DD or Win64DD can pipe to the port connector. So that is some recommendation right here. You can collect the image, whatever you want to do. Mandiant Memorizer is can some kind of, you can GUI interface run on a USB device. HB Gary FastDump, no more developed because the company is not exist anymore. And some other tool, one quite famous called WinPMAM. They are the only open source tool for Windows OS. So if you want to check and download the sample to play around, go here. Okay, find the KPCL. We can start up the Win kernel debugger and then type the exclamation PCL. You can find the PLCB, and based on PLCB, you can find quite static location for XP that is basically in a particular location. Win7 based on particular stable location right here. You can play around with your Win debugger. And I'm not going to do the demonstration. Another command you can using in the volatility that is called the image info. When you're using image info, it will display you the location offset of the KDBG, which is the physical address. Of course, these image info, when you type in, when you capture the image, it will also show you when this image was created and show the timestamp for you, and also some of the content location or what kind of version of the system. by typing the command called the KDBG scan. And both KDBG scan and image info is important because when using volatility 2.6 or previous version, you need to know which profile. Profile is referring to the kernel structure, object structure provided by the volatility developer. But in volatility 3, you don't need the to provide the profile because the profile is determined by the online download from the Windows server. They take that kind of approach in volatility 3. So I just run some example on Win7 Surface Pack 0 and Surface Pack 1. I can find the same location of the KDBG for this version by typing the image info. So it's quite interesting by using this kind of thing. Couple of slides more so that I can go to the demo. Okay, what can we find in the by using volatility for a memory dump? So string is some basic, you can use the string, and then other than that, you just treat it as a using a tool like a live forensic environment, sysinternal tools. You can use a memory range version. You can assuming the volatility is a memory version of the following tool. You can check the memory dump at a particular instant of the system, like the Process Explorer, PSList, Handle, DLL, TCP view, because TCP will talk about the socket. You can check, you can find the socket, you can find all object, you can find the memory map, you can even find the registry inside the memory. And once, not the least, the last but not the least is the Win debugger. You can using a volatility as shell, just like type command, just like a Win debugger to check the structure and the content of that memory dump. So I already covered that already. You can using some quick skilled copy and paste to type the command. Make sure you have the profile. If you don't have the profile, you can set up some global variable called volatility profile, and then you don't need to type the details. And also the file name, what's the location. Here I show the location of the MNN HGFS here, not sample. That is a previous slide. Previously, I named my share folder called the image instead of samples. Then the basic structure. Basically, you need to type both py. In Remix machine, you don't need to type the Python. Basically, we already configured the system with the Python path name. Whenever you type py, that is automatically referred to Python. And then you need to type in the file image location, the file, F means the file. And then you need to type the -- profile equal to the profile name. And then you type the plugin without dash. So if you want to get help, try to type volatility, plug in the name and then help. And if you type the info, it show you all the plugin available to your version of volatility. Then sometimes you need to output information, so you can type the output file. You can change the timestamp to UTC, type the local, do some kind of translation. And then you can, for example, to command, you can type without profile, because we need these two commands to find the profile. Okay. So here's some more option you need to know. If you see any physical address, sometimes you need to, for example, you need to dump a process inside hidden process inside the volatility. You may need to provide the physical offset. How can you find the physical offset? When you find out some brute forcing way to find the hidden eProcess structure, And then that is basically, they are called the PS scan. If you're using PS scan, it will show you the virtual, no, it will show you the physical RAM address instead of virtual address. So you need to type in the offset 0 byte of the image location of that particular hidden process, and then you start the dump. And then you need to provide also the PID of that process, hidden process. Even though they are hidden, remember the PID reside in a particular location of the process structure. Once you can find the process structure, you can find the PID. Based on that, you need to provide the PID plus the offset, physical offset of the 0 byte of the hidden process. Then you can dump it. And also you need to provide the dump. The dump is the location directory of the process dump. So sometimes you need these three options to find to using a special kind of plugins, such as dump process. And you can write your own plugin, and you can provide your plugin to your path. So this too is important. I don't want to spend a lot of time. You just type file name and then image file, image info and KDBG. You can get this information to provide the profile. How to analyze malicious process? Basically, you check the image file name and then find the profile parent process, process start time and command line any will residing in the memory. And then analyze process activity by typing the PS list, which is find the all the process in the double linked list enumeration. So you it will not be able to identify any hidden process because of DKOM. Yes, PS tree just show the output in form of a tree by checking the child and parent relationship. Still remember the exercise that I demonstrated in the window internal part. PPID and PID is the key to draw the PS tree structure. As I said, PS scan is trying to find the eProcess structure in a brute forcing way. So it whenever, even though it is unlinked through the DKOM, the PS scan can find this process. PSXView is one of the most important demonstration I want to show you. We combine everything together using different kind of way to identify any process identified, including PS scan and PS3 and some other I will explain in the demonstration. Okay, so let's go to the demonstration right now. Okay, I have my Remix machine on. I check whether my image is loaded, the appropriate location. Yeah, I have all the image right here. First, I want to check with one of the image called SUSE. So how can I check the image they are running in the SUSE? Then what I have to do is to load py and then image info. Sorry, I already typed the image info. I know it's XP Surface Pack 2. So I type the file location with the -f mn h and then sample, and then is called OneSUSE. Okay, so profile, what's the profile? Profile equal to win window XP Surface Pack 2 x86. Okay, PS list. Okay, if I want to see more, I enlarge it a little bit. You see that it shows the virtual address, okay, and then the table right here. How about if I change my screen, if the 9, I have a better picture. Okay, so that is my information. You can see that how many thread running, how many handle, section table. Later on, I explain to you why there's nothing for this section. Okay, so that is the PS list of shoes. One thing, if I want to show you better picture, I change to 8. Sorry for the screens becoming smaller, because I want to show you more nicely packed picture. How about I change it back to 9? Okay, it's better. You see this, all of these two, because or for the section way to handle to check the process by PS list. And you remember the Windows internal structure, remember the startup of the Windows system. The first process start up by the kernel, and then it will start the section manager, and then it will start by the Windows subsystem 32 subsystem. So this one will start this one, and this two, because the section way to check whether there exists a process, this two is not be able to identify because it start after this section is start after the section smss.exe. So you will see nothing right there. And also there's an interesting one. Even though the terminated process you can see, and termination time, UTC time, you will find that there's no handle right here. Why no handle? The reason is there is no thread. Actually, the thread is equal to 0. Running version of a process is the thread, not the container process. But you still be able to find a container for eProcess, because eProcess structure, even though they are terminated, they just unlinked. The structure is still there. By using some way, if that process is still there, you can still be able to identify it. And also you remember in the eProcess structure, there is a start time and exit time. So if you have exit time, you can find the information right there. Okay, right now I start to do checking another sample called the StartNet. StartNet, you remember I mentioned that is a some kind of malware attack Iran's uranium enrichment facility. By typing the PS list of the StartNet, you will see more information, and also you can see that the before the capturing of the image, there's two commands have been executed: command and ipconfig. And also the same thing, you can identify, are there any hidden process? No, we cannot find by using this command. Then can we do another command called process tree on this .NET? Here you can have the virtual memory of this location likely present in form of a tree, and you will see that the tree, after that we knock on the ipconfig command point, and then the explorer start the process mode. Hey, they are performing the behavioral analysis. Yeah. And also you can find that this virtual machine capture this memory dump is basically an image of the virtual machine VMware used by the image capture acquisition investigator. And I think this is the schedule Java download or whatever. So everything looks good, nothing special for the PS3. And How about then we use checking the image of the shoes. The same, nothing special. How about using another plugin called PSScan? That is the way I told you, using different way, brute forcing way to identify any data structure found in the physical memory. If that is the case, if that is the parser structure, it will show you. Therefore, if SUS are using direct kernel object manipulation way to hide one of the process, you can find it out by using PSScan. Here you find nothing additional, but you can see right now it provides you the physical address, P, not the logical address, okay? If you need to dump this process, you need to provide this address and also the PID and dump dirt in order to dump the process for further analysis. Then can we do any other something interesting thing? For example, how about we try to find information of the by using PSX view. So we try to using PSX view on shoes. And this time we are using a combined method to show most of the information. Okay, with X. It will show you more information, see whether they are a real process or hidden process or not. So by using PSX view, it including part of the PSScan, so all the address shown right here is physical. Then you can see anything true is okay, but false we need to investigate. Why this is so many false? For example, flag, PCIDs, CSRSS, and section and desktop. Do we have desktop for coded terminated process? No. Do we have this kind of section and process information or CSRSS section? The answer is no. So that is, if you find false right here and false right here for this code terminated process, okay, no worry. But what about if the others applying the same logic? Some of them already closed. Because why it is closed? You can find the exit time. Okay, why this is still false? Because system SMSS, as I told you before, they will not start up the section. Therefore, no desktop. There's no CSRSS or PCID. So still okay. So that is the way to identify the information. Now let me move back to the screen of the slide to give you some more explanation. Okay, that is the PSX view rules. How to interpret it? Basically, the only process that launched after the CSRSS, which is the Win32 subsystem, will be available, be seen by CSRSS handle table. So we have to exclude any false in the system process, SMSS and CSRSS. Only process that launch after the MSSS will have the section and desktop. Section and desktop show false for system and SMSS. Okay, don't worry. Process that start with exit, that means terminate, will not appear in this handle table, CSRSS section or desktop. So previously terminated, I showed you already, you don't need to concern. So that is the way how to understand the PSS view by using that kind of thing. You can go ahead to download different image to do further study. the volatility, I just show you the process command, but what if I can do some more? Let me see if I can do some more demonstration for you. Okay, it's difficult for us to remember the structure about the how to interpret the PSX view, but the developer in version of 2.6 of volatility tool actually provide an additional plugin called the applied rules. If you type something like this by apply rule, you don't see false anymore. It will see if everything they are okay, it will show you the command called apply. It will say it is okay. If you still see not okay here, that means that is hidden process. So try to use apply rule with the PS view so that you don't need to remember everything. Okay, for the shoes, for example, I want to analyze it by using another command called con scan. Whenever you find scan, it go through the physical memory to find to using a brute force method to identify are there any kind of process that is containing a socket. So connection scan, con scan, will show that the image previously, even though we shut down the machine, we still be able to find that connection socket structure inside the memory. And you can see that it tried to connect the local address to the some kind of internet IP. Yeah, that is the location to find the remote location. And it also opened a port 1056 on this SUSE image capture. Okay, so that is interesting, right? So how about we do some other command, for example, try to check another image, for example, lab22 memory or StatNet. How about do a StatNet on con scan? They are on the same profile, so I don't need to change anything. Hey, you see that? Nothing right here. You don't see StatNet to have a connection. Okay, so how about we use another command called socket scan for shoes. You see that one of the connection, they open a port right here, TCP6. Okay, so some of them are interesting. You can do your interpretation. Okay, you can also perform a socket scan on StatNet. So other than that, actually, you can't find any hidden process of TKO in our illustration on these two images, but I can show you can find some image published by the volatility developer. They have some sample with the TKOM example. You can download to do a trial. So I, in the slide, I provided additional information. You can using that to do your online investigation and analysis. So that is for today's demonstration. Hope you like the volatility tool and go home to do a trial. Thank you. Bye-bye.